This is section 1.6, number 56. This is another example similar to number 57 in the homework. So we're using these two rules. A to the negative n equals 1 over a to the n, and 1 over a to the negative n equals a to the n. So another way to look at this is to actually rewrite this first. So remember, the goal is to have no negative exponents. So we can rewrite this first, this fraction here, as x to the negative 3 times y to the 4th power times, and then division is the same as multiplying by the reciprocal, right? 1 over whatever you have in the denominator. So times 1 over z to the negative 5th. So we can rewrite that that way. Sorry, that's the dog. So we've got x to the negative 3, y to the 4th times 1 over z to the negative 5th power. And then what we end up with is, so we can, first, we see x to the negative 3. Okay, that's a negative exponent, so we have to change that. We'll use this rule. A to the negative n equals 1 over a to the n. So you get x to the negative 3 equals 1 over x cubed. Okay, so that's rewriting x to the negative 3. Then times, so just to review real quick, the reason these two are equal is I just kind of separated out that multiplication. This is x to the negative 3 times y to the 4th in the numerator, and then it's divided by z to the negative 5th, which is the same thing as multiplying by 1 over z to the negative 5. Okay, okay, so we've got 1 over x cubed for x to the negative 3. Y to the 4th, that can stay the same. And then 1 over z to the negative 5. Well, from this rule, we can say, okay, 1 over z to the negative 5, that's just z to the 5th power. Now we multiply across 1 times y to the 4th times z to the 5th. That's y to the 4th, z to the 5th. And x cubed is in the denominator, so we bring that over. X cubed stays x cubed, and that's our final answer. Hopefully this helps. Let me know if you have any questions.